learn a little bit about OpenAI from Joel and OC, and I'll let him introduce himself in a second. But many of you have been here in the past, so Azure User Group in West Michigan, we try to meet every second Tuesday of the month. It's usually around broad topics in Azure because Azure is so big. And we'll let Joel do his thing for the majority of our session. We'll leave some time for networking and discussion around other topics. And I will once again at the end ask you all for anyone who wants to present as we look into next year. The schedule is wide open, so lots of opportunities, and we can talk a little bit about that too. But yeah, so in case you're new to this spot, if you need the restrooms, they're back through the door, a little bit to the so you keep going right, and you'll get to them. Other than that, it's a nice learning format. You're feel free to ask questions however you want to, or if Joel wants to hold them to the end, that's fine too. But any questions and any thoughts before we start? Fantastic. Well, thank you very much, Joel. I'll turn it over to you.
Thank you, Brian. All righty. Good afternoon. My name is Joel VanderWeide, and I'm a senior consultant at Vervint, formerly OSD USA here in Grand Rapids. And the presentation I'm going to kind of dive into today was what we did with Azure's OpenAI. Specifically, we called it Genos, and we told everybody at work that it was coming to take their jobs. However, if you have taken a dive into GPTs, LLMs, any AI offerings and things like that, most of us well know that it isn't, in fact, going to take your job. Largely what we've seen with some LLMs and some things like that is they kind of turn into BS generators pretty quickly if they are not well tamed and well groomed. So what is it actually that we built? What it turned into was a markdown content indexer. Specifically, we were looking at documentation around some of the technical stuff that we had built in the past for clients, client engagement documentation, anything like that that we could kind of encapsulate and then start to either play with, search on, or things like that. What came about was a utility that effectively was a semantic search and semantic memory. I'm going to dive into kind of how that all played out and what that means. But then out of that, we created a web application around this to help manage the content and some of the flow of the content. Very, very simplistic little application. And then the kind of the true power that we were trying to dive into was our use of Slack. With Vervint, Slack is like our communication lifeblood. And so trying to tie some of the knowledge that we had gathered, some of the knowledge that we were hoping to retain around clients, and align it to channels in Slack that made sense or provided value for development groups, client teams, client engagement groups, things like that. So kind of a high level why we did this. First of all, OpenAI has been a hot button. It is an offering that has come about with a lot of hype and with a lot of quote unquote promise within the business community. Business leadership are eyeballing it as a $2 trillion, and I think that's probably a conservative estimate at this number. It's probably higher than that by 2030, just for incorporation into applications, integrations, system level, back office processes, anything like that. Everybody is grabbing onto the new thing and going, where does this work? So we kind of did the same thing. But what we did is we put this in an internal project trying to reduce risk. We're a consulting organization, and so trying to do something off the cuff and bleeding edge like this isn't really something that our clients want to buy into necessarily. So we were afforded the ability to kind of take this internal and do a project group within our team to try and see what we could gain out of this. Of course, we love emergent technologies. I know that's kind of a cliche phrase, but that's what this is, because it largely came about, at least with Microsoft, in February. So we wanted to gain some access with it and try and understand what was going on. Also out of that, a desire to create internal tools for us. As I was saying, we've run into situations where retaining client knowledge or retaining project knowledge gets difficult because either that documentation doesn't get done or is left with the client or is left, honestly, God knows where sometimes. So the idea around this was to try and collect knowledge, retain it a little bit better, but then also have a utility that we could search on it and hopefully come back to at a later date and time if those engagements pick back up. The other interesting thing that it was kind of more of my take on this, but was Microsoft's, and I'm not going to go into it now because it's pretty lengthy, but Microsoft's documentation on responsible AI and their approach to responsible AI. I really liked, kind of the face that they put on around making this accessible and making sure that it's accessible, making sure that it's clean, that it doesn't contain, racist or bigotry or any like terrible kind of things that we're not trying to surface up for the larger, greater audiences that might use these products. This also goes into potentially like creating services and utilities for people with special needs, handicaps or things like that prevent them from necessarily being able to integrate with a computer like most of us can do on a daily basis. So some interesting takes into there and more to dive into as far as their approach and their take on AI. But one of the things that I was really taken aback with was the fact that they had come out with this right out of the gate. So now kind of starting to dive into the technical. I'm not going to read these, but some of the terms, because this was taken from another presentation for the company internally. But some things that we're going to kind of approach and touch on a little bit is prompt engineering. That's kind of some of the foundation of this. We're going to talk about how and where the prompt engineering portion fits into our whole system, along with vectors, embeddings, and cosine similarity. Those are all pretty well tightly coupled together. For anybody who is not up to speed on OpenAI and some of its offerings, it not only is an LLM, but also offers what they call their embeddings endpoint. This embeddings capability will take text data, run it through basically a vector generator, and will then spit out a multidimensional vector array that represents your content that you have fed it. This whole piece is pretty important. I'll again get into this in a little bit too, but that vector embedding process is the entire search capability for our application, as we'll see here. And again, the algorithm that we are utilizing for this is cosine similarity, which again, Lucas could probably speak to better than I can at this point, but as I'm to understand, is a relatively standard vector analysis algorithm as far as our use here and with these OpenAI vectors. So to get started, what do we have to do? You can't just deploy an OpenAI service and start using it. What Microsoft has currently in place is gating around that. I think largely because they're working on deploying these resources out to data centers. There's also probably cost analysis on their side as to whether or not this makes it worth it. So as part of the process, they have you go through, fill out an application, speak to your use case, kind of identify your business and the subscriptions that you want this deployed to, and then they give you the ability to deploy these resources. Once that flag is turned on, it allows you to then deploy the OpenAI, cognitive services OpenAI, and even there's a bicep module for it too that you can even deploy as well. So they're kind of jumping right on that as well. This process was relatively quick for us. I don't know if it's because of how early we jumped on it, because this was, I think, late March, if I'm not mistaken. And if I read correctly, February was when they kind of then batched the OpenAI service under cognitive services. So we jumped on it pretty much as soon as we could and heard a quick response back. I don't know if that's still the case. So your mileage may vary if you go through the application process at this time, but when we went into it, it was less than a week, and we heard back, and you're like, yep, you're ready to go. You can deploy 3.5 turbos and everything that you need. So just know that if you are looking to integrate with OpenAI on Azure, that you do have to go through this process. You do have to go through an approval, and you have to identify the subscriptions that you'd like to deploy to. But after that, you get the full capabilities of your favorite infrastructure as code language to deploy these, or if your preference is through the portal, that's fine too. So this is getting into more of the nitty gritty of our application. So when I mentioned earlier, like what our process is or what our utility is a content indexer. The first thing that we took an approach on was what is our data model for that content to begin with, and we called that a paper. The idea being a paper is a full source writing on either a subject or part of a subject, but would be topic specific, contain sections just like you would see in normal documentation. And all of that then is brought into Cosmos DB as that paper object where the content is assigned there. We have a paper approval flow here that you see a diagram for in a minute. But out of that, we take the papers, and then what we do is we call it chunking, but it's taking that paper and breaking it down by sections. That worked out to be a really important piece for our search algorithm and kind of how we handled digging into that content. Reason being is based on the chunk size, you may or may not get a really great response out of some of these. The chunk size is one of those, it defines your section content or the size of your section content, but has implications around querying. So if you don't have a chunk size that's large enough, your query may miss that chunk as an important piece or as an important referential item in its search, and you'll see in a demo here in a little bit what that means for what we did as far as returning data back. Embeddings in this process were a one-to-one with chunks. So as soon as the chunk was created from that paper, it immediately went into an embeddings process. Through the web app, we ended up creating a lightweight paper approval workflow that handled that for us, but also then came back and if you edited content, it would clear out the embeddings, run back through the chunking process and the embeddings to make sure that the data that you had saved as part of that subject that we were creating was not dirty or did not contain anything that we didn't want. So the importance here, as we'll see, is that both the chunking process, the embeddings, all come into accuracy of search. Excuse me. So as you can see, we intake papers through a number of ways. Ours was really just a script that we ran on a folder to import markdown files. Through this, there are automation steps. Obviously, you can work, storage accounts and function apps to do that ingestion. You could even look at, eventing or data pipelines from, say, a CMS as your input for this. But really, anything that would potentially be that automation pipeline for content can be fed right into this process, and then hopefully provide at least a searchable value for you. On the back end, you can see we leveraged Cosmos DB. It was an interesting choice at first. Cosmos DB was kind of our first take at document storage. And largely what we're looking at was our kind of our organizational, or what we were most comfortable with as far as data organization. There's also, as we'll see here in a minute, an offering by Microsoft for MongoDB under Cosmos DB that actually works a little bit better for this, but we'll explain that here in a minute. But we started out with Cosmos as that was kind of our understanding of what Microsoft was heading towards as far as using a data backend for this. It worked out pretty well, all in all, with a couple of little oddities here and there. The other thing we tied into and utilized was Microsoft Semantic kernel. If anybody has searched around for that, I would suggest doing so. Or if you have not, sorry, I would suggest doing so, especially if you have interest in AI. I don't know what their direction is on it, but it could be likely that SDK that pairs with OpenAI and that integration going forward. The semantic kernel at that time was a little rough. We pulled it in, and again skipped that integration or skipped that MongoDB backend and instead used Cosmos. Out of that, we had to again make some adjustments, including our search algorithm, which meant pulling most of a partition from Cosmos into memory to search on. As we'll see, the Cosmos DB capability doesn't have that same database search capability that MongoDB does. That would allow us to, losing my connection here. Sorry, 1 second. There we go. I don't know what that was about. So where was I at? So like I said, we started using Cosmos DB as our backend, but all in all, probably not the direction that we would want to go long term. If I had an option to do this all over again, it would be utilizing that MongoDB capability, because then we can offload the cosine similarity algorithm to the database instead of pulling that up into memory and doing it ourselves. Semantic kernel offers a lot of other functionality around the OpenAI integration. Like I said, I would encourage you to go dig into it. There's a lot of information and examples in Python, Node, .NET. Yeah. Moving on. So out of all of this, really fun Azure architecture diagram, but really simplistic all in all. John Fulberth would like this diagram, but it is probably a little bit more than what was really actually needed. We took an approach with function app microservices. We used Cosmos. A lot of this was to save cost, honestly, right out of the gate. We tried to minimize that as much as possible. Reason being is, well, we were an internal project. We didn't have a budget. So it was like, well, what's the lowest we could get on it? So basic web app services, consumption, APIM, consumption function apps, base Cosmos, that sort of stuff. Service Bus was there for handling the Slack integration and some backend eventing, but really lightweight all in all. Okay. So I'm going to skip the content ingestion. I don't have that prepared, and ultimately isn't probably the cool part of all of this. The automation of that is neat, but really it's what you get out of this that's probably cooler than that. I know I'm speaking probably to the wrong group, saying that message to the wrong group. You probably are all like, no, we want to see the automation part. But in reality, this is what the integration here looks like. So I have, in the back end, I've created a what I will call a subject. That subject, aligned with that partition key in Cosmos, directly aligns with this Slack channel. So it's a one-to-one relationship. It does not go across boundaries. It is isolated to that. The idea being, in case client-sensitive information or anything like that was allocated to a specific channel, it would not be available in another one. Again, another point as to why we went with Microsoft as opposed to any of the other services. Because again, everything exists within your subscription. You're not dealing with boutique services across the internet or anything like that where you don't know where your data is living. And for our clients especially, that is of utmost importance. So what do we get out of this? So this channel was preloaded with some information about the embeddings. Largely, this documentation was pulled from the Semantic kernel repository. I chucked it into here is just to kind of show you what gets produced out of this. So in our embeddings flow, we then, when it comes to user prompting and querying, we take that user prompt. That also gets embedded and then is utilized as the comparison vector for our search vector behind the scenes. Or sorry, for our content vectors behind the scenes. That content, based on, what do we call it, heat score, but it's like closest match, or I'm not sure. Do you remember what the score on that was officially? Not P score, but yeah, different. Yeah, we'll figure it out later. But forgot where I was going there. But anyway, so out of this, we take the user prompt, embed it, and then pass that into the service as the user prompt. The system prompt or the system message is a concatenation that is made up of, as I was saying, the prompt engineering portion. That is our prefix portion of the system prompt. It explains, what the character is, who the character is, their attitude about certain things, and how they're supposed to respond, including that if they don't have information in the context that's provided, that is the second section of our system prompt, if that information does not exist in the content, then it is told to not respond. So it doesn't have enough information. As you can see here, I asked this question yesterday, is this thing dead? I'll do it again today, /Chinos. Short answer is going to be yes, because things have gone to sleep. But if I ask the question again, I should get a reliable answer of I don't have enough information of that. Because the question I asked it, or the information I'm looking for, has nothing to do with embeddings, with cosine similarity, with vectors, with any of that Euclidean geometry behind the scenes. But now if I go and I ask it, /Genos, if I can type, I ask it, how are vectors used in cosine similarity? It's going to think, and it's going to give me feedback. So this prompt has been told that it should respond with a full message, generally 3 paragraphs, that it should take its information and comprise a response from its context, and then deliver that message back in basically in format. So the real use of the LLM here is in the response generation exclusively. We've kind of stayed away from the large, ask it the anything from the internet sort of thing, and try to refine it down. So we get out of this an explanation. I'm unsure of this. I haven't read it right off the bat. It could be a hallucination. It could not. I think we've hopefully isolated down some of these hallucinations. But if we take a look, I have a link out then to our site. Forgive me for the design on this. It's not terribly pretty, but it's useful internally. Where we can actually go back and reference the original documentation that generated the response from our AI. So we can go back, we can make sure that the response that the AI has generated isn't BS, that it is actually based on the documentation that we fed it, and that we can check to make sure. Again, these subjects are pretty narrow and don't contain a ton of information. Again, more to play with on that in future iterations, because I do believe that the amount of content that is available to be searched on in these subjects does have implications for quality of response, as well as whether or not it dives into some of the more niche details or some of the side details around the question that you've asked it. We felt like this was an important piece, again, because of the capabilities of the LLM to produce hallucinations. We felt like it was important to be able to reference our query back to the documentation that it came from so that people could then go, yeah, okay, that makes sense. I can trust that and then answer and I can move on. The other goal of that was then for a future capability where we would be able to say, approve or disapprove, basically a thumbs up, thumbs down of this response, which we would then store in the database. The hope being that these could then potentially be used as fine-tuning data for the LLM at a later date and time. If it was potentially desired that we wanted to take that route, we would have the capability of doing that through an approval process or a thumbs up, thumbs down on these answers. Again, as I was saying before, each of these are ranked by heat score, and you can see, which ones are the more pertinent information or where the vectors grabbed most of their information from. That is largely what that number means. So, let's see. Actually, let's do this. Does anybody have a question they want to answer about any of this? What's that? Sorry, I can't hear you. Oh, like where it came from? Yeah. It's its origin story? Oh, yeah. Okay, that's right. I remember that. That's actually in a different channel, Lucas.
So are you defining the channel by the data and on the back end? In other words, so what you were asking before was more the documentation theory behind it?
Mm-hmm. Yeah, so that documentation in that channel was solely isolated to a partition in Cosmos that was that subject. So that channel, we actually use the channel ID in Slack as the partition key in Cosmos to direct tie all of that information. And so in our query in the back end, we pass that across to pull that information up. So again, we've created what I call like a content or knowledge silo with that strategy. I'll give you an idea as to why we did that here in another few minutes, but I don't know where that information went. We've played around with this a lot, so yeah. But again, we could ask it things like, how are hallucinations generated? It might not know. Actually gives an idea though. Confident responses that are supported by its training data. Yeah, so in this case, there is no training data. We haven't actually gone through and done an LLM fine-tuning on any of this. It's simply pulling from that content silo in the data backend.
Can you ask it how it came to the relevancy score? Will it break out confidence level?
I think so. Let me see here. Okay, well, maybe not. So this is a really good case. We don't have documentation on that. So what do we know we need? Documentation on that. So there's a twofold in this. So not only does this give you the ability to then search your data, search your information, make sure that it's correct, make sure that it means anything, but it also gives you a tool to go, wait, I was supposed to get an answer out of that. I need better documentation. I need more documentation. I need clear documentation, or I need more pointed documentation. So all of this is kind of tying into that too as another use case where the LLM or the use of the integration with OpenAI, the LLM or the embeddings gives you the capability to vet your documentation, vet if it's searchable, because ultimately you're largely going to bring this up to an end user, is who your target audience is. So if your end user, in this case, isn't able to figure out how to search, then, or if you would put in a question that would be a normal query of theirs and you come up empty-handed, then yeah, it's back to the drawing board with our documentation and we need to fill out our content a little bit more. All right. Well, okay, so I hit the wrong button. That's a me. So what do we find out in all of this? Content accuracy, architecture, organization, and quality are key. What this turns into pretty quickly is more of an MLOps approach. And what I mean by that is instead of your content going into a CMS, instead of your content just kind of dying on the vine there, or being delivered up to your users through traditional query methods, or just grabbing at it and chucking it at this AI or this LLM, it doesn't really work. There's a lot of care that has to be taken into that data, again, as we saw, refining it, making sure that the content is there, that it is, that it makes sense, that it is searchable, and that it is kind of developed and explained well enough so that the LLM has the capability of doing that vector match against that data set. That's also, there's also a key takeaway there in the ML ops approach in that it's very much analyzing if this is, for your use case. The semantic, semantic memory utility that we had created may not be necessarily the greatest at devising or coming up with or giving information that supplements your original query, but it is more direct as far as say its accuracy or specificity on the information. So if your use case is, say, policy related or Department of State or some sort of governmental agency related, whether that's law, policy, or anything like that, then you have to be very, very careful at how you implement this utility to then respond to your end user as that expert. Depending on legal stance there, that may or may not be the right approach. But our other takeaway, as we were talking earlier, I would gut this whole thing and do it over with the MongoDB vCore and Semantic kernel. Unfortunately, that is like $200 monthly out of the gate. But for the hobbyist, not necessarily the the greatest approach. But for most of our organizations, $200 a month as a stepping stone into this is a pittance. So, yes, sir. That is MongoDB vCore under Cosmos DB. So it is a Cosmos DB configurated offering. So yeah. Yes. Yeah. I did not see the capability and the semantic kernel documentation and Microsoft's documentation at large doesn't really go into any of the other offerings. It doesn't talk about it. It's again primarily the cosine similarity algorithms, those search algorithms. Again, your difference with this is the MongoDB vCore has those capabilities built into the database system, so that you don't have to pull it up into operational function memory or app memory to then operate on it. You can do it as part of the database. Right. I don't quote me on that. But I don't think so. I think this is pretty tightly coupled, but again, more research into that. Yeah. But yeah, I would I would take the same approach. Now, would that affect data modeling and data architecture? Likely, as I would have to dive into more of the specifics there. But again, the approach would be to try and align, those content silos. Oh, sorry. Yeah, one of our other key takeaways in all of that is we actually submitted an issue around this Cosmos architecture and how to query it. Our coworker Carl put in that. And later this summer, they went, yep, we're just going to cut out Cosmos. So the Semantic kernel library, actually, they've completely cut out the Cosmos offering because a couple of PRs opened up around that issue, basically surfaced the fact that the way that Cosmos operates does not allow you for great integration here. So they and I guess completely breaks some of the data and collection architecture. So instead of trying to reverse engineer it to make it work for Cosmos, they just decided we're going to cut it and go with the MongoDB vCore next, which is again part of our part of the reasoning here. So diving into the future, what does this all mean? My hope for this is to iterate on this application and build out capabilities. I think there's a use case and a potential interest in, say, a prompt engineering playground, and that actually pretty tightly couples with point number 3 around the idea of a character. The reason that we did these content silos was the potential to take a heavily engineered prompt and create a character out of it that would direct one-to-one with that content silo, effectively creating what I'd like to think of it as like an SME, where you could approach a certain character within your application, have a conversation with it. We are one shot at this point in time, but conversation capabilities would come later, where you would interact with that character as that SME for that specific subject. You would converse with them, query them, get knowledge out of them, and then based on your query, based on the information that you were looking for, potentially jump to a new character. Through more automation processes, a whole bunch of over-architecting and over-engineering, we also kind of came up with the idea that there would be like a top-level character we called the archivist that would then send you into the other ones. But there's some distillation on those subjects, and then creating a data set that archivist could then query over that actually worked for sending you into the right character was something that we hadn't totally figured out yet. So actually point 4, the potential for persona alignments. So for e-commerce applications, for your .com product catalogs, for that sort of thing, most of you have probably seen or experienced the persona aspect of e-commerce sites and utilities like that. Recommender engines, things like that are all driven off of this. So based on the recommendation analysis of the persona, they may align you to a character specifically. I'm thinking of Home Depot's website, where you log in with your user account, and based on your purchase history or things like that, you may get shuffled off to a character that is the contractor persona, somebody who's going to be say, communicating with you or feeding you information or data that is more aligned to what contractors or what businesses would purchase, as opposed to the handyman or my DIY self, where I've got to do some personal home updates. That's a completely different persona that might take me into or guide me into different communication experiences that then would lead me into various products or things like that. So the real thought pattern there again was aligning those content silos and character creation, so that we could hopefully align with like a persona or create a character that was a subject matter expert to query against. Unsure of long-term value in that, but I saw the tie-in with the e-commerce and some of the web persona stuff, and figured, most of those sites also have chat bots tied into them, but they're really just like telephone trees. This then starts diving into quote unquote more of a human-centered approach as far as how the developers or the application would communicate with the end user. For us, it's internal. Yeah, 100%. But yeah, what do you like specifically?
Unfortunately, our data structure, the right person with the right knowledge can get into some really deep financials in the business very, very easily.
Okay.
Right? And so I'm looking at this like this would be fantastic for a lot of our customer data.
Yeah.
But if this thing goes rogue and I ask it, okay, what's the HR director's salary?
Got it. Yeah, that's information you don't want. That comes back to what we were talking about before with the ML ops approach and making sure that the content pipeline that you're feeding into that is highly refined, that a user has taken care to make sure that some of that isn't getting out, which is actually an easier process to do than bullet point number 5 here, where the ML ops approach generally takes a dive at custom tuning models themselves. Again, these are more related to data models and not necessarily LLMs. But the idea of custom tuning an LLM for that sort of thing starts getting very, very expensive and may not be the use case. However, depending on information accuracy or, again, some of that sensitive data, a fine-tuning approach at some point may come into play here to help guide that away. Yes. Yeah. Security. Yeah, the security first approach is one way to go about it. Yep. Again, depends, but yeah. One of the other interesting things, bullet point number 2 up here, is the idea of skill and protocol development. This came again out of the Semantic kernel repository and some things that we had seen throughout some other offerings or other talks and sessions. But this idea that the prompt could be engineered heavily to perform an operation, like write an email, create a marketing blast, any number of things that may not necessarily be high data sensitivity sort of things. See, Matt, but could be utilized in that case. That may even be utilized for customer messaging around alerts or things like that. If you have catastrophic system failure or even minor system failure and you don't want to generate a full database of response messages, this could come into play to help explain some of that too. Again, with a large amount of development behind it, but yeah. So that skill and protocol development is kind of paired directly with the prompt engineering capability, but is of interest, I think, for us down the road too. So there's other things with that too, and again, I encourage you to explore the Semantic kernel repository, because again, there's a lot of good information and data there around these capabilities, especially the skill and protocol stuff. You'll see a lot of examples in their library. All in all, thank you. Thank you for listening to me babble on here for a while. And then if anybody may have caught, Genos is actually, we stole it from One Punch Man, if anybody is an anime fan, but we named it after Saitama's AI assistant, personal assistant. So that's where the name came from. But with that, any questions? Any more questions, comments, thoughts, anything like that? Yes, sir.
In theme with the title of this meetup today, Taming the BS Generator, you have some good examples of maybe some BS that was provided you or some good hallucinations that the model returned to you when you were testing it out and trying different things?
Yeah, we tried to get it to write code. Specifically to spit out unit tests, because what we had actually, this is a future goal too that I didn't actually have up on the slide, but was hoping to dive into GPT-4 to try and do some of this code gen stuff. But yeah, so one of these here, Carl asked it to generate a unit test, and we did have some unit test examples in the back end, but it didn't use any of our examples. It didn't use any of our scaffolding, any of any of the example code. It wrote its own. It did use fixture though, so that was nice. And then another one where it wrote it in Python after we told it to write it in C#. Some of the other ones were again around our prompt engineering portion. So if I took off of this the stipulation that it has to answer specifically from the context, then it starts going out of bounds, out of the context that we gave it, and then hallucinations become very real very fast. With the potential that it goes off the rails quick. So that's why we're saying like heavily prompt engineered things steer us away from that. But yeah, we've seen across the board some early stuff with this that just was like, where are you getting this from at all? Which is why then we added the referential documents and that heat score so that we could make sure, because we saw it doing some weird things. But yes, sorry. Yes. Yeah, that is part of the approval flow too that we had within the website, and is kind of I wouldn't call it a stipulation, but is, as we discovered with this, a necessary gate, that there is the content generator, the person who derives or builds that content, and then there is definitely a follow-up step for said, say manager or expert level person to then come in, review, refine, and then finish the acceptance pass of that to then chunk it and embed it. But yeah, right now it's very manual as it takes a human. Could I see more automation of that in the future? Yeah. I didn't dive too far into this, but I was playing around with an idea that this could become a potential. Are you familiar with SonarQube? All of you, it's a utility that will go through and scrape your code, tell you where your problems are, all that kind of stuff, let you know you're out of date packages and potential security issues, things like that. We were thinking that a utility like this could potentially be leveraged to actually quality gate content, so that content creators, the marketing folks, the people who are writing all of this would go through the same process that most of us developers do with creating the work, peer reviewing it, using that this potential tool as to highlight areas that don't make sense or that might need more refinement, and then person comes in, reviews, approves, and moves on. So I see it potentially in that case, but I think the tooling has to mature and grow a little bit, or I think an intentioned approach with this integration too. Yeah. Very. Yeah. So her question is again kind of that delineation between do I throw the data in the database in the content silo, or do I train the model? The point on training a model that you have to think of is that you can never roll back a model. You can never roll back an LLM. So whatever you do has to be refined before it gets into fine tuning, because if you fine tune it wrong, you blow away your model and you start all over. So just a little cautionary tale that yeah, if you mistrain your model, again with any AI model, If you mistrain it, it's, well, blow it away and start over because it has learned things in sequence that it cannot then roll back and forget. So to your point, our capability, it's very quick because we go back, we can update that paper. Once that paper gets updated, it blows or deletes from the embeddings database that embedding data, runs it through chunking, runs it through the embedding again, and then has a new set of vectors to query against for the next user query. Retrain, yes. Yeah, heavy air quotes on retrain. Also, heavy air quotes on that because Microsoft hasn't even opened the fine-tuning API endpoints up for the OpenAI services. So right now, you cannot. So they got all the documentation for it, but none of it's there. So, yes, sir. Yeah. I think, Lucas, correct me if I'm wrong, I think it's actually character counting, to be honest with you. Or is it taking markdown sections? Okay. Yeah, so we started, yeah, okay, that's right. We started out taking markdown sections. So in your markdown document, you have your top tier and then you have, those sorts of sections. So we broke it out like that. That worked out pretty well. And then we actually kind of toyed around with the idea of controlling that chunk size and being able to expand that out a little bit. The other reason that was important and why that came into play was you have token limitations for how much back and forth you can do with the OpenAI service. So if you're taking an entire paper and you're only using a very small section of that, you're wasting 90% of your tokens that are going back and forth between that OpenAI service. So we chunked it like that to break it down so that we hard focused on that content and then trim down our basically our token usage. Again, cost cutting entirely. But yeah, that chunking process is integral to that cost saving mechanism. Yeah. No, you're all good.
So you're saying the call to this OpenAI API into Azure, there's a set call cost, if you will. So you're saying you're trying to say if you go too small, let's say the sentence in the whole, you're going to pay the same as the paragraph level. So you're trying to optimize.
Yes. Yeah. As I was saying, so what we do with this integration is to first query the database subject, that partition, using that vector array. So you can see in our embeddings database. I'll just bring this up here. This? Okay. Yes. This is built. There's an on the OpenAI service. There is an embeddings endpoint. You take basically a content string, you feed that content string to it, and it spits back this vector array as its response, and part of that response. Yep. Yeah. Yeah, there is. You're digging into, I think, a point that we didn't get a chance, unfortunately, to really put some data analysis around. But to your point, that chunking piece or the amount of data that you then set into the LLM to bring back that response, that when we turned it down, it had a more difficult time. So when it used smaller chunks, it had a more difficult time searching and had a more difficult time generating a response out of that. And yeah, again, if you go too big, then you lose potentially, some of that finer detail or some of the finer context around that. So it's a bit of a fine line that we found. So again, yeah.
So you're right. If it has too much, you can't shrink it to where it actually knows the context of what you're looking for. And if it has too little, is So there's that sweet spot. It's generally around 150 words per vector that the semantic search is going to use. Use either this tool or there's other ways to do this too, but it's a sweet spot for sure. And they're marked down chunks. I'm guessing it's basically if they see heading 1, that's a chunk. If you heading 2,
Yep, that's a bingo. Yeah, no, we are breaking the document up specifically by those heading tags exclusively. So yeah, sees one, it goes up, that's a chunk, and it will break that document down when it's ingested appropriately. So yeah. A lot more data analysis and what I'm going to probably call some ML approach to trying to figure out that sweet spot a little bit more. But yeah, around the 150 was where we felt like if you go bigger than that, it's not too bad. If you double that, it gets stupid. And smaller than that, it doesn't give you anything meaningful. So. Yeah. Yep. Yeah. Any other questions? Comments? No, this isn't going to be what you want to grab to try and make $100 million with some cool AI thing. The Dolly stuff isn't going to be your thing either if that's what you're going for. But if you want to throw it in one of your applications and make a cool integration, yeah.
So a question, Joel, about the role that the semantic kernel part of the puzzle plays.
Yeah.
Do you add anything to that? What is that specifically?
Yeah. So what it's doing specifically, well, we leveraged it, I think, exclusively for that cosine similarity call, if I'm not mistaken. Where things were at were very rough at that point in time. So we didn't want to build the cosine similarity algorithm by hand. So we were like, okay, this utility has it. So we grabbed the semantic kernel, and it can do that as part of at least the version that we were using. It could do that as part of its SDK. Yes, sir. Yeah, the chunking is a process, like a quote unquote proprietary. There we go. Can't words. But is specific to Markdown, where we take the headings of the Markdowns, of the Markdown documents, and that becomes the chunk. So if you've got a document that's one top level heading and a whole bunch of text, you might want to think about adding some section identifiers in there for chunking purposes if that's your go-to. But yeah, sorry, I thought about diving into the code, but there's too many hoops to jump through to get to at this point in time. But yes, that is. We just pulled in the repo, pulled in the library, and started playing around with it. Yeah, so.
Well, thank you very much, Joel.
Thank you. Appreciate it.